Hi everyone, in this video I'm going to explain work done by torque. A torque is defined as a turning force which acts at a distance from the point of rotation, or is the energy conveyed to a point of rotation through a distance. Or a torque is defined as the turning effect of a force about a point. So if you look at this picture, this is the point of rotation, and this is a distance, and energy is conveyed to this point through a distance. Just like a moment, when a moment is applied on the point of rotation, there will be no turning effect, or the energy conveyed will be zero, the moment or the turning effect. Now, the formula to calculate torque, we use a symbol T, and since it has something to do with force that is conveying an energy through a distance, it will be force multiplied by a radius. A moment is a force multiplied by a distance, but when it comes to turning effect or rotation, we just use the R. A force must be measured in newtons, and the R, the radius, must be measured in meters. Now, if a radius is not given in meters, you must first convert it to meters. Number two, as you can see here, this is the point of rotation. So the energy is conveyed by this force through this distance. So this distance is the radius. When a force makes a full revolution, so let's say that you turn this nut from the starting point, right, all the way back to the same point. So it's going to describe a radius or a diameter or a revolution. Now let's have a look at this. If a force describes a full revolution from this point from point A all the way back to the same point, at distance covered, torque is given as force multiplied by a radius. So at distance covered, when a force describes a full revolution, is the circumference of the circle. And the circumference of the circle is given as pi d, where a diameter is twice a radius. So circumference is pi multiplied by 2r. When we arrange it, this will be 2 pi r. This is the circumference. So when a force describes a revolution, this will be the distance covered. When we calculate a torque, this is the formula to use: a force in Newton and the radius in meters. So this is the SI unit of a torque, similar to that of same as that of a moment. A work done by torque will be given by, general formula is force multiplied by a distance. But a force, if it's given in kilograms, you always convert it to newtons. The distance, one revolution, is 2 pi r. If we arrange this by putting 2 pi first and F multiplied by R, F multiplied by R is equal to the torque. So work done by torque will be equal to 2 pi T, only if it describes one revolution. So this is for one revolution. But if it takes 2 revolutions, 350, 420, how do you calculate work done? if it takes many number of revolutions. So we can generalize this equation and say for any number of revolutions. If it's 2 revolutions, this formula will be multiplied by 2 because it's for 1 revolution. 3 revolutions multiplied by 3. So if it's 450, 720, or any number of revolutions, this work done by torque will be equal to 2 pi nt, where n stands for number of revolutions. So if it's the small letter n, this will be number of revolutions per second. So n is equal to, or the SI unit is a revolution per second, or RPS, revolution per second. Now, you can be given the number of revolutions per minute. So when n is given per minute, it will be capital letter N. And this capital letter N stands for number of revolution or rotational frequency. It's number of revolutions or rotational frequency. So when it's per minute, it will be capital letter N, which is a revolution per minute, or RPM. Can be written like that. Next thing, the relationship between small letter n and capital letter N. If you are given 350 revolution per minute and want to change it per second, you're going to divide this by 6 because in 1 minute there are 60 seconds. So it means that small letter n is equal to capital letter N divided by 60. This is how you change from revolutions per second to revolutions per minute. So work done is given by this formula, 2 pi nt. And the answer we get here is a joule per second because this is measured in revolution per second. And a torque is Newton meter, which will give you a joule. So the SI unit will be a joule per second. If you want to calculate work done in joules per minute, this formula will be W equal to 2 pi capital letter NT because this one is meters per minute, revolutions per minute. So the units here is joule per minute. Now to calculate the rate at which work is done, power. Power is a joule per second. We get power or we get a single watt when we have Q equal to or P equal to rate at which work is done. So if this one is in joules and time is in seconds, we get a watt. So to calculate power, it will be this formula because this formula gives us joule per second. So power for work done by torque is 2 pi nt. So it is compulsory for power to use the small letter n. It's 2 pi nt, same formula as work done. Work done is in joule per second, but for power, you put watts. Now let's look at the activity. The activity taken from a question paper of April 2023. It says calculate the diameter of the pulley if an effective force exerts a torque of 105 Newton meter on the pulley. So this is April 2013. You want to calculate the diameter if an effective force. Now let's look at the solution. So not all the things that cause that turn will be applied when you tighten or you loosen a nut. We can have a drum. or we can have a wheel. If it's a drum, a question can be, this drum is hoisting up a load. So this load will be the force that you use to calculate torque. The one that you say torque is equal to F times R. So this will be the force exerted on the circumference of that drum or the wheel. So if it's given in kilograms or tons, you convert to kg and multiply by 9,8 to get a Newton. So this will be the force here. Now a radius, this is the shaft that passes through the center of that drum or the wheel. Now a distance from the center to the circumference is called a radius. Now a relationship between a radius and a diameter is that diameter is equal to twice the radius, or the radius is equal to d divided by 2 is half of the diameter. Now in this question, you are given the force as 130 Newton and the torque as 10.5 Newton meter. It says calculate diameter. Now you come to formulas. A torque is given as F times R. So this side is given as 10.5 equal to a force is 130 multiplied by a radius. A radius is the unknown. So there is no formula that involves diameter, but you can get a radius, then you double it to get a diameter. So you divide both sides by 130, both sides by 130. This radius will be equal to 10.5 divided by 130 is 0.081, 3 decimals after the comma. 0.081. It will be in meters because this is a Newton meter and the force is in Newton. So this is in meters. A question can be specific and say calculate this diameter in millimeters. So this is the radius. Diameter will be 2 times 0.081 because it's twice the radius. So multiply this by 2. When you multiply by 2 is 0.162. This is 0.162 meters. When you change it to millimeter, it's 162 millimeters. That will be the answer in millimeters. Let's look at the second example. Second question. From April 2019, a mass of 800 kg. So you always write down the given. M is equal to 800 kg. Is lifted by a drum of a lifting device. The drum has a radius, so R is given as 400 millimeters. Okay, we are calculating the torque delivered and the work done for 1 revolution. So N is given as 1. Let's look at the solution. The mass of the object is 800. So which is to get the mass, the force exerted on the circumference. It would be F or W equal to mg, where the W is 800 times 9,8. So a force, you must calculate it by using the weight of that drum. It will be 800 multiplied by 9.8, and the answer is 7,840. It is in Newton. Next thing, you can calculate the torque. The radius here is given in millimeters. So if you still remember, King Henry died miserable death called Metz. This is the general SI unit. So it's a meter that we want, belongs there, basic SI unit. Now from milli to meter, 1, 2, 3. You move to the left 3 times. So it means we're going to divide this thing by 1,000, or we move to the left 3 times. So this R will be 0.4 meters. So a formula will be torque equal to force multiplied by radius, which is 7840 multiplied by 0.4. And the answer will be 7840 times 0.4 is 3136. So the torque is 3136 Newton meter. Next question says calculate work done for 1 revolution. So work done, which is W, is given by 2 pi nt. That is the formula to calculate work done by torque. 2 pi nt. So it will be 2 pi, n is 1. It says calculate work done for 1 revolution. Let's look at the question again. Calculate the work done for 1 revolution of the drum. So you are not given diameter, you are given a radius. If it was a diameter, we were going to halve this radius so that we can get R. So all we need to do here is conversion, because this is already a radius, just to take it to meters. So N is 1 and the torque is 3136. You get the answer, which is 2 pi times 2 pi multiplied by 3136. N is 1. So the answer that I got is 19704. 19704.069. It will be in joules. Since this N is not per minute, so this answer will be in joules. It's not per minute, it's not per second, just say for 1 revolution. But when the time is included, your N will be per second or per minute if it's big N. Now, a question can be calculate work done in kilojoules. You already have this answer. So from a joule, which is general basic SI unit, to a kilo, 1, 2, 3. You move 3 times to the left, 1, 2, 3. So this answer will be 19.704 kilojoules. That's it. Some formulas will be given in exam. I will show you which formulas will be given in exam. Thank you.